All right, let's get started. Good afternoon. Today, what we're going to be focusing on is what data lakes look like in the context of the advent of AI. Because it's moments like this where it feels like everything is changing, and it kind of is, but on the flip side, there's a lot of data fundamentals that I think are going to continue to reassert themselves, and keeping those lessons with us is super important. Before I get too far ahead of myself, my name's Charles. I'm a founding engineer and VP of engineering at Airbyte. Really, in my career, though, it feels like it has been a litany of rebuilding ingestion pipelines over and over and over again, regardless of what job I was at, even if that company was not particularly a data company. And so, fundamentally, my mission at this point in my career is to get to a point where tooling is good enough that software engineers don't need to spend a lot of time thinking about ELT anymore and can go on and focus on whatever the key differentiator is in the product that they're building, which is a good segue into today's talk. And so I actually want to start with history. The modern data stack, maybe dead now, but was this incredibly exciting time in the data space, and so much innovation came out of it. But there was also just so much wasted effort in the modern data stack as well. As you saw tools that had existed in the software engineering space for decades get rebuilt. And so as much as the modern data stack pushed forward what we were able to do with data, I also felt like if we had not had to rebuild all the stuff that had already existed, we would have even gotten further in that movement. And so, as is probably the case with most good talks, I'm starting to hear takes about AI in the context of data lakes, and I go on the internet and I just get angry, and I was like, I gotta go talk about this a little bit. And so, fundamentally, what we're gonna come back to today is that there are so many lessons about how we move data that are still applicable in the AI world. And I would love to make sure that we don't make the same mistakes as the modern data stack. We don't reinvent the data wheel, so that we can focus on all the actual cool stuff that's happening in AI and all the innovation that's coming out of it. The way I want to structure this talk is I'm going to give 3 snapshots of what I think the future might look like with the advent of AI. But before I do that, I want to start with what I think the world looks like today. And what I'm going to use as a through line for this talk is a single case study. And so we're asking the question of our data. We have a blog post, it seems to be really popular, but is it driving high value conversions to our product? And so high value in this case is the notion of maybe a higher or premium tier in your product. Hopefully this doesn't seem like a contrived question. We were asking a question just like this internally at Airbyte the other day. And so what I would argue is, in today's world, if you're trying to look at what the best practice is, you're going to pull your Google Analytics data because we're talking about a blog post. We're going to assume using Postgres as your application database. And then we have Stripe there because that's your payment gateway. And so you might want to pull all of that data into one spot because you need all of that data in one spot in order to answer that question. So you might use an ETL tool like Airbyte to do that. Then you're going to put it all in a data lake or data warehouse. We're at an Iceberg conference. Iceberg, great choice. And then you're going to build business tables on top of this data. And the business tables are something we're going to come back to a few times in this talk. They're incredibly important because they take all of this raw data and they allow you to define a domain model that makes sense in the context of your business. It may feel like what a customer is obvious, but when you're actually pulling that from multiple different data sets, there's a lot of choices you have to make there, and there are a lot of ways you can do it wrong. And then finally, someone comes in, uses some sort of data visualization tool, maybe Metabase, who knows, to actually write a query that gets you the answer to this. And so I would argue this is the best practice in today's world. And you might argue, why do we need all this stuff? That's a ton of things that you're talking about. But fundamentally, the thing that you always come back to is that you need to pull all of your data into one place to answer most interesting questions. And so much of what we are trying to do today with the ELT and data lake stack is to avoid re-extracting and rewriting data. I don't want to go too far back in time, but you might remember the days of ETL where essentially the idea was let's transform data in flight. That was a pretty good paradigm in a world where hard drives were still expensive and you didn't really have a data warehouse. So you didn't actually want to land a ton of data in a given destination. Nowadays, hard drives are super cheap. Data warehouses and data lakes can store tons of data. And so that really changed the way we thought about this. Essentially, you get to a point where you want to extract your data and then load it into your destination in as raw form as possible. Why is that? Because it's the extraction and loading of data that ends up being incredibly expensive. If you imagine trying to even pull not that large a data set from any given API, that is going to take much, much longer than if you have that data materialized in some sort of database management system. And so we're always trying to avoid the re-extraction piece. On top of that, you want to stick the transform at the end after your data has been materialized, because that's the most volatile part of your data stack, usually. Whether you are iterating on how you want to describe your business tables, there's a bug in how you've done your transformations, or you're iterating on how you want to think about the questions you're asking your data. And so transforms happen a lot, and if those are coupled to the extraction, that gets really expensive, both in terms of cost and time, really, really quickly. I then want to emphasize that this problem actually gets like a lot bigger once your data actually gets big. Like everything we've talked about now is like a little Postgres data, like it's actually not that big, but once you start moving to like petabyte range, like this idea of avoiding re-extraction becomes even more important. And it's like easy for this to feel like kind of intellectualized. So like I want to walk through an example that I've lived through actually a couple times in my life to like really hammer this point home. So you can imagine we have a database table. We are collecting Disney films in it. So we're using integer as our primary key, an ID, which is an integer as our primary key. And then we have film titles, and we'll just sort of abstract away a bunch of other stuff that you might find in this database. And so we're going ahead, we're making Disney films, you know, a few years later, we're on to like Frozen 10, Black Widow 9, and like, suddenly we have a problem. Avengers 101 is a bridge too far, and our database is saying there's a problem. And the problem that it's trying to tell us right now is because we have used an integer as our ID, the problem in Postgres, for instance, is that the integer space runs out after 2 billion, et cetera, 647. And so once you try to add one more record in there, it says, I can't do that. If you've ever experienced this on a production system, it's really a nightmare, because usually your way out of it is that you now have to run a database migration to take that integer, probably turn it into a big int. But the problem with that is at the moment you've hit this ID number, you're experiencing data downtime. You're not able to churn out any more Disney films at this point. And then as you are running this migration to change the type of your ID column, you're generally seeing some sort of degradation of your database, because what's happening under the hood is that it is rewriting 2 billion records. And so fundamentally, the thing to grok here too is that like we're still not even talking about terribly big data. Like this is all data that fits on one hard drive, right? And so take this lesson and apply it to a world where you're actually talking about distributed systems. And so yeah, finally we run our migration, we're back to big int, and we are back to churning out Avengers films, and we are happy. I want to take a look at what this would look like using Iceberg, though, because Iceberg has this really beautiful concept of virtualization of schema. And so in the world we had previously, where we were stuck waiting for a database migration to run, we were experiencing data downtime for an extended period of time. In Iceberg, however, because you're just using a metadata file in order to describe your catalog, essentially as soon as you realize that you've run out of integer space, you can tell your schema, I want these to be interpreted as big ints. And what is going to happen there is any data that you've already written, it is going to be able to interpret that data. It's going to be able to cast it to a big int, so you're not experiencing any data downtime on your existing data, and it will be able to write any new data using that big int. And so by decoupling the schema and the way data is written, suddenly you're in a place where you're avoiding a big problem. And so essentially the lesson that we need to pull out of this is you really, really, really want to avoid ever rewriting data, especially when you're getting to any sort of serious data size. And so this is the drum that I'm going to beat for the rest of the talk. Please, 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 let's avoid re-extracting and rewriting data, even as AI becomes a bigger thing. All right, now we're on to the fun stuff. Let's start looking into the future. So you can imagine the FOOM future. So this is like AI takes off in such a way that it's self-learning. It's kind of the master of everything. And so let's like take a look back at our case study. How is the agent going to go about trying to answer that question? I would argue that in this world where we're in like sci-fi level AI, the agent is going to come in, it's going to realize it needs to move some data, it's going to invent a data movement tool, it's going to build some integrations into the places it needs to pull data from. It's then going to realize that it makes sense to materialize all of that data so it can query it, so it's going to invent a data lake. It will move the data into the data lake and execute a query. Now, I think in this world, like most things being discussed at this talk, become irrelevant. And so, you know, like maybe this should be alarming, but like If that's the world that happens, like that's fine. There's not a whole lot of worth planning for. And so I think that's like, as much as it's like fun science fiction, it's not the area to like spend a ton of time on. I don't spend a lot of time worrying about it anyway. So here's the future that I hear a lot on the internet. This is the one that makes me angry. And it's from people who know a lot about AI, but then are like maybe not that steeped in the data world. And so they're like, okay, we're going to go in and try to answer this question about conversions of high-value customers. I think what will happen is the agent is just going to it's going to just query Google Analytics, et cetera, because like agents actually are pretty competent at querying APIs. It's going to pull all that data into memory, and then it'll have an answer. I think this is actually a really unrealistic outcome. I think the first thing to call out is this drum that I'm beating it is not accounting for the fact that you want to avoid, I have a typo there, re-extracting data over and over and over again. And so it is assuming that a data lake doesn't exist and that this is all just going to happen in an agent. And again, you can try to attempt that, but what you're going to find is you'll have a really inefficient agent, because if you have to re-pull all of your Google Analytics data every time you have a question, that is going to be both expensive and a waste of your time. There are a lot of interesting things to get into around access control for agents, because fundamentally, like your current RBAC system and the access you give your data engineers is probably a little different than how you want to think about an AI. You could probably do a whole talk on that, so I'm not going to spend a ton of time on that. And then the last is comes back to the business table. And essentially what I think happens in the future that I've just described here is that the agent is ad hoc trying to rebuild business tables on the fly. And as I was mentioning earlier, I really think the business table is a very important choice that each business makes in order to understand the domain, understand their business. And so if you just throw that at the agent of like, yeah, no big deal, take the data from all of my different data sources and like tell me what a customer is, I think that's unlikely to go all that well. But let's say for a second, like maybe it gets it right. And so it's able to answer the questions like, okay, 10 of 12 premium tier subscriptions came from people who read that blog post. The problem you have there is then you ask a different question or even the same question. There's no guarantee that the agent is going to come in and recompile all of that data into the same notion of a customer. And so then you end up in this place where you ask the same question twice, and you're going to end up with two different answers. And this seems like the nightmare scenario to me, is that just throwing agents at data without the proper tooling leaves you in a spot where no one really knows what they're talking about, and all of the agents don't even know what a customer is. So finally, I want to get to a future that makes the most sense to me. And frankly, I am not an AI scientist by any means. I'm certainly an enthusiast, but like for now, we'll say I have a novitiate hat on. But I've been doing the data thing for a minute now. And so what I think the evolution is, again, using our case study from before, is that we're going to see that agents are in charge a lot more of building a lot of data pipelines. The agent is likely the thing that is setting up the data pipeline to pull data from our different data sources. And agents do inherently work with data a little bit differently. Because they can be always on, I think it is more likely that there are more use cases where the agent is going to want to occasionally pull data directly from the data source as opposed to going to the data lake. You can imagine asking a different question like, what is my invoice balance? There's not a really good reason to go to a data lake where your data might be a few hours old as opposed to just going directly to Stripe for that. Again, it depends on the context and the question you're asking. I would still argue that in most cases, you're going to want to materialize that data into a data lake and then build your business tables around that. I think agents have a lot they can do to help build those, but it's still going to be supervised by a human because it is a lot of decisions that are specifically related to your business. While there is not a right way to build a business table, there are a lot of wrong ways. So agents, I think, are super helpful for helping keep you in sort of like best practice land, but fundamentally, you need to make those choices for your business. And then finally, the agent can go ahead and query the data lake. That's something they're arguably already pretty good at. And so essentially, the reason I come to this future and would argue that ELT tooling and data lakes are still incredibly important, arguably even more so, is because there's going to be more data out there. And in that world, avoiding the economics of re-extracting and rewriting data becomes even more important than it was before, especially for big data. On top of that, there's so much that we as humans take for granted in terms of picking up tribal knowledge within our organizations. And so when you think about an agent, it's not going to be able to figure out the correctness of your data very easily. And the more that you can do to give cues to the agent of, I'm giving you correct data, I'm giving you complete data, and all of the context around that and documentation, et cetera, that is going to be how you're going to get the best performance out of an agent. If you just let it run wild, I guarantee that you will end up with answers to questions that do not make any sense. And then finally, I want to come back to the business table. I think the world where an agent does a lot to change the way the data space works is that the agent is there to help build the business table with a human, and then all of your subsequent questions are querying from the same data set. And so that should increase the chance that the agent, when asked the same question, actually gives you the same answer. Now, we all know LLMs actually are not deterministic, so there's no guarantee of this, but that actually makes it even more important that we remove the degrees of freedom for any question that the agent is asking. That being said, there are a lot of things that do change. Like I was just mentioning, like agents only are going to have access to the data and the metadata that we give it. And so while at your company you might sort of know that you use Stripe, the agent doesn't know that you use Stripe unless you tell it you use Stripe. And so programmatically being able to surface for an agent what your data sources are and what their schemas are, that's suddenly even more important than it was previously. And similarly, with all the metadata, lineage, and documentation around that, they are less able to intuit often what those data sets are, and the more you can do to give them hints is really important. The last thing I want to hit is around low latency use cases. And I think it's really important to talk about today because like everybody here is talking about streaming and everybody's super excited about streaming. And I think agents actually do increase the amount of data that you're going, the number of streaming use cases and the number of use cases where data is pulled directly from a source. That being said, I think the economics of how you process data are going to reassert themselves as they have before. And what we have seen over the last 30 years is that you end up with two flows for your production data operation. The first is for your large data. You go ahead and you run batch operations, let's say maybe nightly, to do any expensive calculations on large data sets. And then as data comes in between the nightly runs, you're able to stream that data into some sort of key value store so that for any question you're able to answer it up to the current time period by stitching together the batch and speed layer of your data set. I think that pattern just continues to reassert itself. And this is like where I come back to, like, let's make sure we take all the lessons of data over the last 30 years, 20 years, whatever. You know, like this has been called Kappa architecture, Lakehouse architecture, Lambda architecture. Let's take all of those lessons and bring them with us and not rebuild that stuff from scratch, because you still need to get these things right to power your agent well. And so in this future, what I think comes out of this is that even though the amount of data being used is growing, you are building an architecture where you are moving data as infrequently as possible to keep the economics sane. And then you are changing the way you set up your data lake to allow the agent to access and use data more efficiently. So as we come to the end here, like basically my prediction for the future is like, if AI takes over, none of this is super relevant, go do something else. But like assuming that is not the case, like ELT and data lakes are even more important than they were in the past, and is a place that you absolutely should be investing to power whatever your AI initiatives are. That's what I got. Thank you.
Thank you, Charles. Guys, please don't forget to rate this session on the app, and I guess this is it. Thank you.